We are happy to have Dr. Henrik Christensen, Professor at the Department of Computer Science and Engineering at the UC San Diego here today in Aarhus for this DIREC talk about research in robotics. So let's get started. Can you share a brief overview of your academic background and how your research interests have evolved from you doing research in Aalborg to where you are today, where you are professor at the robotics at the UC San Diego?
Sure. So I got my education at Aalborg University, and both my master's and my PhD, and was faculty at Aalborg University for a few years, mainly sort of, I would say, computer vision with a flavor of robotics. And then the Swedish community sort of was starting a new center on autonomous systems. And they called me up and said, we're going to give you a serious bag of money if you move to Stockholm. So I moved to Stockholm, became a mainstream robotics professor, more away from computer vision to multi-sensory systems, more AI, more interaction with people, and was in Stockholm for 10 years. And then it was time to do something else. So I've sort of moved every 10 years through my life. Then I went to Georgia Tech and ran a big center called Robotics Intelligent Machines. So very much sort of the interface between robotics and artificial intelligence. And then after 10 years in Atlanta, I've heard the West Coast, sunny, very nice, and said, let me go to San Diego and see what we can do. And they were starting a new center called Contextual Robotics. So I went out there, started this. So it sort of moved from mainstream computer vision to robotics to now being robotics and AI.
Mm-hmm. So having worked in different countries and at different universities, what is the difference between doing research in Denmark and doing research in the US, and what can we in Denmark learn from the way they do research in US or in Sweden?
So I think I think in the US, all research is extremely impact focused. If you can't tell me what the impact is, it's about, are you publishing in the right publications? Are you making sure that you're really publishing results where the impact factor will be much higher? So there's a lot of focus on impact. Make sure you're not focusing on mainstream things. You have to do sort of really think about what would make a difference, what would make you have major impact. Whereas, and I would say even so, Sweden has a very long tradition of very strong academic communities, like the Royal Academy of Science and those things that very much sets the research agenda. And I feel in Denmark we are less focused on sort of this. It's more the individual universities define their own priorities, and it's less about big initiatives. It's sort of this trade-off between how much should we focus on science and how much should we focus on the engineering. And there I feel in Denmark we're very good at making sure we do research that's relevant for industry, that's sort of in a long term, but we are less sort of focused on the strategic long-term impact in comparison.
Is there something with the size of the grants that you're able to get? I spent half a year at UC Berkeley, and there was a lot of DARPA money, and somehow if you have a big budget, maybe you think bigger than if you have a small budget, or have you observed something that how does it impact the research, whether or not you get a big grant or a small grant, or how do you see that?
So, of course, I'm a co-director of a large institute we have on AI and optimization, and it's $25 million. So that suddenly we're talking, there's not that many $150 million kroner grants in Denmark where you can, and this is, we're one of 25 of these AI centers. So there's a lot of money floating around, and then if you go to the defense sector, there's a serious amount of money. But I think in Denmark it's less obvious what is strategic. Whereas if I take the example to Sweden, in Sweden, the large companies, ABB, Saab, Volvo, Ericsson, and all of the medical companies are sort of saying, we do the applied research. Don't worry about applied research. We already do this. We need the university researchers to be thinking about what is long-term strategic, where are the big wins. So they're sort of saying, we will support you, we'll give you money, but we need you to think really big, fundamental, at the edge. Whereas that, I still think that's true in Denmark. That's less, here you're supposed to both do the strategic research and the more applied research. And it's not like, in some sense, we don't have big companies in Denmark. Well, we have Novo and we have Lego and we have a few, but it's very few in comparison. So there's not the same push from industry to sort of go in and say, this is what we do, this is what you should do. And for that reason, it's more modeled in Denmark in comparison.
Interesting. Okay, let's focus in on the robotic research. So if you look back during the last 5 years, are there any kind of major breakthrough in robotics that have pushed the field forward, or can you maybe shed the light on some of the key challenges that robotics researchers are interested in?
So good question, and I think it comes in different varieties. So we're seeing tremendous amount of progress on material research and on nano. So we're seeing it's now possible to build hands that has sort of a sense of feeling. We can integrate this 3D printing, and materials have enabled us to do much more interesting embodiments of robots. We can build robots that we had never imagined we could build before. That's sort of one. Then I think the other area is that we made tremendous progress on sensors, cheap sensors, but also, if you need to put 5 cameras on a robot, it's not a big deal. And at the same time, we have the computing power. So we have the sensors, we have the computing power. We've gotten to, when I was a graduate student, we were doing 64 by 64 images. Today, that's sort of, people say megapixels, so it's very different. And so computing power has really changed that. And then I think the last thing is through use of modern AI, sort of deep learning, language-based models, these very hybrid, has completely revolutionized how we think about it. So now we can bring in data sets that are the size that we could never imagine before. So as an example, I have a autonomous driving car driving around on the UCSD campus. It generates 4 terabytes of data every day. So that suddenly implies that, when I comes in, I just bought a new 100 terabyte backup disk. They said, okay, so next month you're going to go and buy another one. So now we have to think about petabytes and storage systems. So it's possible we can do this. It opens new opportunities, but it also, in some sense, makes it much harder because we have to think at a scale we never had to think about before.
What kind of research challenges, or what are the challenges we have not solved yet in order to really make an impact for instance, nursing homes or other of these labor-intensive areas?
So there, I think it's very much about, we've solved what I would call the easy problems. We can do better pattern recognition algorithms. We can do behavioral analysis today of this. I can predict where people are going to be 15 seconds from now. So if I'm seeing them in a hallway, I can navigate around them. I can do this. But the real of building usable user interfaces is really hard. And it more typically we leave it to a computer science professor. And I'm saying, no, we need to bring in the cognitive science people. We need to bring in these other disciplines. We need to work with the designers on doing better sort of design of the robot, so they, we should not let engineers design these robots. They're the wrong people for it. And at the same time, we should not let the HCI researchers on their own design user interfaces. We should bring in the cognitive scientists that understand about mental capacity and interaction patterns and all of this. So I think it's very important that we leverage all of these other fields to be able to build systems where so far we built them based on computer scientists and engineers. and we haven't realized that we're good at some things, but our shortcomings are on really modeling, whether it's the world or the people or all of these, and that's where these other fields need to be. And so I think that's the limitation. We see things where I look at it and I will say, yeah, that was designed by a computer scientist. And we're not, it's not, we should do the final implementation, but we should help build much better embodied models using knowledge from other fields.
So that's the case where the computer scientists say it's working, and it's still in the closet, and say, hey, it's not working because it's in the closet. Yeah, but everything is working. But then it might be because it's not easy to charge, or it's too cumbersome to move over the doorstep, or something like that.
Exactly. No, so small things like, so I remember 25 years ago, I worked on the first autonomous vacuum cleaner with Electrolux. And we designed this amazing robot. And then I gave it to my mother, and 3 days later, she called me and said, "Henrik, it's driving around in circles. What do I do?" And I said, "Oh, you go into the menu system, you press the second button, and it'll be fine again." And then my mom said, "What's a menu doing in my robot?" For her, that's what you get in a restaurant. It's not something that is in there, because she's never used a computer. So it was a clear lack, from my point of view, of appreciating what is her conceptual model of the world. And we need to be much better at understanding the users and integrating it than we are today.
And it's the same in my home. We are not using a robot vacuumer, mainly because we have Lego on the floor. So again, unless it's able to kind of like clean up the Lego, then I cannot really use it, even though it's perfectly capable of vacuuming.
But even simple things. So we did so one of the things I've done at UCSD, at Georgia Tech, was started with 25 homes where we gave them Roombas, and we studied it for a long period of time. We sort of looked at what were the reasons why it failed, what were the reasons why it was being used, and one of them had this beautiful designer home, and we came out and I gave them a Roomba, and he looked at it and said, "This looks ugly. I don't want to use it. I'll put it in the closet." And when we came back a week later and said, "Did you use it?" He said, "No, I forgot about it. It's in the closet." So understanding people's everyday patterns and how you get it integrated, understanding that you have to Roombadize your home, remove the Legos and all of this before you can use it, and that makes it more or less useless.
Interesting. If we go to another big topic, it's climate change, and of course there's robots involved in all different areas of climate change, but if you should point to one or two cases where you see robots really making an impact or being on the forefront of the solution and not just kind of like an assistant part of it, what comes to your mind?
So I think this is an example where we can look at places where robots are complementary to people, in the sense that we can for instance, go underwater. So we've designed robots to go and pick up plastic waste. So in the San Diego Bay, there's lots of plastic coming in. And by using robots to basically do the same thing as the vacuum cleaner, but doing it underwater, we can pick up a lot of plastic that it's unrealistic for divers to go and actually do this, because it would be too boring, it would be not healthy. And we're now moving this out of the San Diego Bay and into the larger area and looking at doing sort of ocean cleanup at a level that you couldn't imagine to do in a human sense. And at the same time, the reverse of that is that in the area between San Diego and Hawaii, on the bottom of the ocean are sort of what is called nodules. And the nodules are sort of football-sized objects that contains most of the minerals that you use to build batteries for EVs. And the problem is that if we went down and used sort of the equivalent of a big vacuum to suck up all these nodules, then you would basically ruin the ecosystem in the Pacific Ocean. By going out and building robots that can go and pick up these nodules, but not ruin the rest of the ecosystem, it's sort of acceptable to do it. So this is an example where we can use robot technology to have a really big impact on. We want the EVs, but at the same time, we have to find a way of being sustainable, of retrieving the materials that goes into batteries.
Another area I'm thinking of, and one that you mentioned in a previous talk, is this distributed manufacturing or print on demand, whereas instead of shipping goods around, that we print it more locally or assemble it locally. So we are still not there that I can get my Lego box printed in a store around the corner or my T-shirt. So what kind of problems do we still need to solve in order to push this distributed manufacturing forward? And which industry do you think would be the first one to adapt a distributed model?
So that's a good question. So, and my long-term vision is, what if you had an autonomous driving truck driving around in your neighborhood, and you had a factory in the back of the truck, and you would order something, and while it's en route to you, it will happen. I think the first industry will happen is in the fashion industry. Being able to sew jeans or dresses for women, where you go in, you get body scanned, and you get so that they know exactly what your measurements are, and then you can basically sew it on demand and you can deliver it. It's high value, it's extremely customized, and at the same time we're starting to get sort of robotic sewing machines that will actually make this possible.
So are we there today? Can you make a robotic sewing machine that you can fit into a man?
So you have robotic sewing machines today that are being used not so much for dresses for women, but actually for soldiers. Because you can't afford to buy uniforms from another country if you potentially go to war with them and you don't know what's in the materials of your uniforms. So uniforms are being made locally today, and we're just starting to see robotic sewing machines for sewing uniforms. So it's totally unmanned, and it's small enough that it would actually fit into the back of a truck. It's not going to be soldier uniforms, it's going to be dresses for women.
So if we keep these kind of hot topics, then there is generative AI, and one of the problems with generative AI is that they have no sense of the real world. They only have sense of kind of like the written world, and a lot of researchers think that the next level of generative AI is when we plug them in with sensors and giving them access to the real world. How do you see this intersection between robots and generative AI?
I think it's going to be, I think we've just scratched the surface. So I think we've seen it now for language-based models, because we could basically suck up all the material on the internet and use it to train these very large models. But there are other areas where we have a lot of data, whether it's for driving cars around in the world, or it's for grasping objects, where we now have terabytes and terabytes of data. So I think we will take what we've learned on language-based models and move it over to sensor-based models, and we're going to see a complete revolution in how we build these systems, and they will become much more capable. And by doing, for instance, things like grasping, so you can handle everyday objects, it will now become possible to do much simpler programming of this, because today we're programming in Python or something very simple. By getting to a generative model, I can now have a high-level programming language that can use much more abstract primitives, and by doing this, we can get to things of functionalities for sensor-based robotics we've never seen before. We have a project at UCSD where we're using this to clean up a home. So the question is, can I build a model? It would drive around and say, wait a minute, that cup shouldn't be here, it should be in the kitchen. And then it will go and actually, after a party, pick up everything, put it away to where it's supposed to be. And then, so this is an example of We'll see this for cleaning up homes. We'll see it for much better programming at individual things in the automotive factory. We will see this for logistic tasks where it's much more simple to say, could you go and pick up all the parts for this Lego kit? And the robot will actually go and pick up all the pieces because it knows enough about where the warehouses are and the layout of the warehouses so that you can do it at very high speed and with very little programming.
So instead of learning the robot how to grasp a cup of coffee, then you train it with a lot of Netflix series, and then based on that, it has seen enough people drinking coffee to know how to operate a robot arm.
So there's an example from EPFL where they had a robot that watched a lot of YouTube videos and learned how to cook. Mm-hmm. So literally, you would learn all the different things. So, I don't know how to cook an egg. Okay, let me find a YouTube video for how to cook an egg, and then it would sort of learn all of these skills and be able to put it together and eventually can make a complete meal. Mm-hmm. We will see this. Yeah.
Let's see what happens if we feed them TikTok videos of cooking instead of YouTube.
So but that comes back to, what is the quality of the data we're feeding to this? But also I think so the biggest challenge we have with a lot of these systems is we need more AI research on verifiable AI. Mm-hmm. We need to be able to guarantee that it's doing the right thing. We need to make sure it's not abusing it, so it's putting salt in instead of sugar or something like that. It saw it on TikTok and yeah, that was really cool. And people are like, this tastes terrible. What can we do? So I think we will see a way where we need to think much more about what can we do for verifiable AI, because for a lot of these, we also have to think about safety and security. So we need to think about this. And as an example, we have a project right now with Amazon where we're not allowed to use neural networks for any part of this. And it's building a safety system for detecting people in warehouses. Mm-hmm. And none of the current standards that exist will accept a neural network-based implementation, because if something goes wrong, you can do sort of explainable. Why did you detect or why did you not detect that person in that hallway? And we say, well, there's a function that says it's 34. What does 34 mean? So we need much better mechanism for this. So Amazon came to us and said, you can't do any neural network. We still want a safety mechanism. So we had to go back to old traditional pattern recognition techniques and decision trees to be able to come up with an implementation, which when they gave us, that's easy. We will put in a neural network, it will work really well. And our reference implementation uses neural networks, and it's very good, but it's not certifiable. And we're using this as our ground truth, and then we're implementing a old-fashioned AI method that then gives us a reasonable performance. Mm-hmm.
Now, before we talked about self-driving cars, and you had one driving around the campus, I also know that you were involved in the DARPA Grand Challenge back in 2005 or 6 or something like that.
Something like that.
So where are we today if we remove the hype cycle? You talked about your robot generating a lot of data. If you take Teslas and stuff like that, they must have a huge amount of data. What are the problems that are still difficult to tackle when it comes to self-driving cars?
So there's no doubt if we go on the highway driving today, you can sort of you can say from ramp to ramp. Once you're on the highway until you get off the highway, that part there are no pedestrians, there's no bicyclists, there's no skateboarders. It's a 1D problem. They're all driving in the same direction. Solved. We have performance that are sort of commercially viable. You can do this, and we see this deployed on Teslas. But at the same time, if you now go to the city, we're still nowhere close, because you have all of these pedestrians. But also like there was just an accident in San Francisco where a fire truck came and ran a red light because we were going for this. And the cruise vehicle had no idea, so it ran into it. And there was a person injured from this. So where you need, And it's hard to, if you think about map out all the cases. We're just going to send it a bunch of data and hope it will do the right thing. Instead, we have to be much better at contextualizing and understanding this, but in a way where it's sort of accessible. So in California, the manual for how to lay out roads from the Department of Transportation is 503 pages. And nobody's going to read 503 pages and figure out how to program it. That's where we can bring in sort of the large language models to really read all of this and then figure out how do I now bring it back to my procedural system in such a way that I can actually execute it on a car. And we're not there yet. We've just thrown a lot of data at it and hoped it would work. So it's very important to really understand this. It's also important to understand context. If we look out the window here, there's a traffic crossing, knowing when do people come up, when do I know if they're going to cross onto the road, when do I know if they're going to stay on the sidewalk. All of this, we're nowhere close to understanding. But also, so most people don't realize this. If you pick up your phone while you're driving, your spouse might have said, I need a liter of milk or something like that, and you look at it, from the time you looked at your phone until you have full situation awareness is up to 35 seconds. So 35 seconds is a lot of driving distance. So now, we're talking about building, so for autonomous driving cars, we're talking about 5 levels of autonomy. So 0 is no autonomy, 1 is sort of basic driver support, 2 is where you do automatic parking, 3 is what Tesla has, where you can drive on the highway, 4, the car will tell you when it needs your help. And that would imply for some of these, we would have to have a car that can predict 35 seconds into the future, I'm going to need help for you. Could you focus on the road, figure out what's going on, and be ready to take over? We have no algorithm today that can predict 35 seconds into the future what does traffic look like. And because of this, it will take a long time to get there for an urban environment with all of these different players. And now think about snow, foggy conditions, rain, all of this. So it's very hard to contextualize all these variables.
Yeah, and one is a European or American city. Another thing is if you go to India or other places where you might have even more things happening in the city centers.
No, exactly. So this is still very, very tough out. So I think it's at least 10 years out.
Another area where robots are really making an impact is in the current war we have between Ukraine and Russia, especially drones. And it seems like there's a new competition going on between making drones, shooting them down, jamming them, and making them robots for jamming. This kind of like test bed for drones and robots in Ukraine, has that made an impact in the research community or the funding agency, or do you think it will take resources away from other of these robotics area, or how do you see the recent development in terms of robotic research?
I know it sounds harsh, but those kinds of deployments really helps us, because there's very few cases where you get to test your technology to really figure out how good is your technology. So if we go back, and so we didn't see much progress in drones until we had the war in Kuwait, and when we had sort of the war in Afghanistan, that resulted in more or less Afghanistan being a test field for drone technology, and that made a lot of the drone stuff take off. Now there's been sort of a period where we've not had this, where we can deploy technology. We don't have to worry about it, because in public airspaces, it's very hard to do this. But still, for all practical purposes, I've said since 2016, we can fly even commercial aircraft without pilots. So if I look at it, if you look at the Boeing 737, the average pilot engagement time is 16 minutes. So when I flew from the US to here, and it was a 9-hour flight, the pilots had 16 minutes in the start and the end, and the remaining time they played computer games or whatever they do up front, but they were not needed. And in practical, we could do automatic landing and automatic. The only reason why we can't do it is, first of all, we don't have the legal framework to do it, and second of all, the pilots are going, no, we need to be on board. But for most of them, you could actually be in a control center where you could be managing a fleet of airplanes and doing this. So I think we will see it happen for freight, air freight. You know, I'm not willing to go on an airplane where there's not a guy sitting up front. But for air freight, if we lose sort of an Amazon package, it would probably be okay. So I think we will see this, but it's not a technical issue, it's a legal issue of when can we get to it. And at the same time, I think we're seeing this developing much better frameworks for when can we deploy drones in commercial applications, whether it's for agriculture or emergency or all of these. But we need these where we've sort of gotten enough hours of testing and evaluation. And unfortunately, the war in Ukraine and Russia has given us many, many more hours on this. But it would be nice to have much better testing without necessarily having to have these sort of weaponized conflicts.
Mm-hmm. Okay, I have one last area, and that has to do with entrepreneurship. I know you have started a number of companies. How do you see the entrepreneurial scene for robotics? Do you need a lot of capital to make a robotics company? And are there special areas where you think, if you were to advise students to go look for startup opportunities, you would say these are promising areas for doing a robotics startup?
Well, a couple of good questions. So the first part is, it's much harder to do robotics than it is to do sort of general AI, because the problem is that it involves hardware. Mm-hmm. And for software, you can sort of do rapid prototyping, set something up, test it in a matter of months. When you do hardware, it's almost impossible to do anything in a matter of months, because the development cycle is just so much longer. You need to get sort of a viable economic hardware alternative. So typically, it's much harder to get investments for robotics than it is to get it for AI. And for a robotics company, you have to give them a runway of 1 or 2 years to be viable. Whereas for an AI company, you give them money for 3 months and you have to deliver. So it's much easier to get money, but you also, the risk of getting sort of not getting A or B rounds is much harder for the AI companies than it is for robotics, because the robotics, it's a longer, patient sort of play to do this. So it's harder to do robotics entrepreneurship than AI. And right now, then if I have to look at it geographically, it's harder to get venture funding in Europe than it is to get it in the US. In Europe, in the US, there are hundreds of venture capital companies, relatively easy access to venture capital. And if you've done sort of one company, when you come back and want to do the next one, it's a relatively easy effort of actually getting access to capital. So for Europe, you have to be a little bit more careful. There are efforts underway to try and start some better venture funds in Europe, because some of the big investment companies are saying, wait a minute, this is an opportunity. US is red ocean. There's a lot of competition to get access to the funding. In Europe, there's very little access. This opens an opportunity for setting up new foundations for doing this. So I think within the next few years, you're going to see a change, because more of the big multinational investment companies will go after Europe, because there are opportunities here that are not being leveraged. If we go and look at specific areas, I would go for the things that are sort of robotic specific. So new embodiments, so new hands, new fingers, new ways of building locomotion, new ways of doing this, and then new ways of sort of building cyber-physical systems, because there I think there's some opportunities. So the general AI area is so hyped in the US right now that trying to compete in that space is incredibly hard. And we're seeing ridiculous valuations, and we're seeing sort of major challenges. So I would say find your niche, be very clear about what you can do there, and then I would say within, as I said before, within the next couple of years, there's going to be much easier access to funding.
Okay. We appreciate your time, Dr. Christensen. It has been a pleasure to having you, and it has been really interesting to get your perspective of what is going on in robotics research. And we would also like to thank you for watching, and if you want to hear more about digital research and technology, then please follow our channel and see our other videos. Thank you very much.
Thank you.